All right, let's get into it. Today we're going to be discussing string theory and inflation, the period of inflation that happened directly after the Big Bang, versus Anthko's theory of time. I have to say this is kind of exciting for me because inflation is highly supported by Anthko's theory of time. Which of course is the fundamental principle that supports the multiverse theory. Multiple universes existing, collinear to ours, or with the inflation theory, actually bubbles. And then, of course, string theory being used to, at a very base level, say that some of the fundamental constants, constant principles of physics are tailored to the universe in which they are existing. Let's start with inflation. Inflation, directly after the Big Bang, the universe expanded and was created extremely rapidly. And then after that, different parts of the universe came to evolve and were pulled together by gravity and started forming in other ways. If we look at this through the lens of Anthko's theory of time, this is exactly what we would expect to see when that initial black hole collapsed and supernovaed to create the universe. Exactly what we would see is this immediate or near immediate kind of cataclysmic shockwave followed by or in conjunction with I want to say implosion, but really implosion so much that it actually explodes. I don't want to muddle it. So everything shot outward, even though there was an implosion, basically a supernova of a black hole. So again, Anthko's theory of time aligns very closely with that. And then once we dig into how the universe was formed with this supernova of the black hole, it does support the quote unquote bubble concept, where the universe may be spherical because those things within the black hole that formed in those inclusions of temporal quanta, which had lower viscosity than the almost solid state temporal quanta that created the black hole. Those would have been dispersed in a spherical or near spherical pattern, whereas the main plateau of what we're calling the knowable universe would have been spread across the plane or parallel or aligned with the accretion disk that floated around the black hole. Thus, the universe would have been created according to Anthko's theory of time. And this also supports the multiverse theory, where there very clearly is the possibility of more than one black hole in space. We actually, I believe, are observing at least one other black hole not too far from the Milky Way. And if that does begin to supernova in its own way, all the matter that surrounds it, that's not part of the accretion disk, would be spread out further into space and would not be part of that spherical shape that was created by that supernova. Thus, there would have to be universes outside of that universe. So if there's another black hole that's not that particular black hole, and that supernovas and creates its own spherical region of space that has a plane where the accretion disk was spread out in a great distance, and things that formed inside that black hole spread out spherically, well, then you would have two spherical shapes, and you'd have random stuff laying around in space between those spheres. So the multiverse theory, well, it's not quite right. It does align quite nicely with Anthko's theory of time. Now, when we look at string theory, just at a very, 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 very fundamental level, saying that the things within the spherical shapes, our universe, are tailored to that universe, that would make sense because the composition of the temporal quanta, the density, the viscosity, and things of that nature are going to be dependent on how many inclusions that black hole had when it supernovaed, which exotic particles were able to bond with other exotic particles and create exotic things within that black hole before it supernovaed, and which specific cocktail, for lack of a better term, composed that black hole. So string theory, again, at a very basic level, I might dive into string theory a little deeper in another video, does align quite nicely with Anthko's theory of time. So just as a scorecard, Anthko's theory of time supports and explains superposition and quantum entanglement. It explains the Big Bang, how the Big Bang formed and why. It explains black holes. It explains the surface tension around our planetary system and our universe. It aligns quite nicely with string theory and the multiverse theory, and it explains quite a bit of things that are disparate. It explains what we call black matter, or I apologize, dark matter, and dark energy. It explains the expanding nature of the universe. It also explains how our specific universe, the Milky Way, was formed into the shape it's in. So no one has yet provided feedback that says Anthko's theory of time is totally crazy, even though it kind of is, because no one's ever looked at it, tested it, and I'm not sure that anyone can test it at this point in human technological advancement. But right now, from where I'm sitting, Anthko's theory of time is supported by all the physics principles humans have come to discover, and even some of the theoretical physics principles that are still being tested and analyzed and modified. Anthko's theory of time seems to be scientifically valid at this moment in time, for lack of better words. Tell me what you think.